Hi everyone, welcome to Doc Hill's Study, where I help you get ready for your National 5 biology assessments. In this video we'll be walking through questions from an official SQA paper. The paper and the marking guide are both produced by the Scottish Qualifications Authority, the SQA, and all rights to that material belong to them. I'm using these resources strictly for educational purposes here on this non-commercial channel to support students like you in preparing for your exams. I'll be using the SQA's marking guide to highlight what answers are accepted, but keep in mind it usually only shows some of the correct answers and doesn't explain the reasoning behind them. That's where I come in. For each question, I'll walk you through the thinking process, explain what the question is really asking, and point out some of the common pitfalls to avoid. If anything doesn't make sense to you, or you want to ask about a specific point, feel free to leave a comment. I'll do my best to help you out. If you find this helpful, please give the video a like and subscribe to the channel so you don't miss any future walkthroughs. Let's get started. All right, question 2. Let's see where we're up to. All right. A group of students measured the mass of pieces of turnip tissue before placing them in different concentrations of salt solution. After 1 hour, the change in the mass of the turnip tissue was recorded. So they're describing an experiment to you here. This is the description of an experiment. The results are shown in the table. Okay, let's just have a quick look at the table. Concentration of salt solution is increasing. So 1 gram per 100 centimeter cubed here, 10 grams per 100 centimeter cubed here. Percentage change in mass goes in 2 directions. Okay, so there's something in here, and then from this point in the concentration of salt solution, the change in mass is an increase in percentage change in mass, and from this point it's a decrease. Okay, so we've got our heads around the experiment. You'll have done this experiment probably yourselves. Commonly it's done with potatoes, but turnip seems a reasonable enough thing to do, especially in Scotland. There's plenty of turnips. All right, and if you're down in England, they call these Swedes for some reason, but then, you know, Bjorn Borg's a Swede, so that's wrong. All right, predict the percentage change in mass in a 2 gram per 100 centimeter cubed salt solution. Right, well, we've got 1 and we've got 3, so 2 is going to be in here somewhere, going to be in here. You're allowed, you can't be expected to predict this exactly, so it's got to be between 11 and it's got to be between and 17. Right? It's got to be between 11 and 17. You can't pick 11 because that's 3. You can't pick 17 because that's 1. So any number between these is fine. Pick something in the middle. 14% will do lovely. Okay, you can put a plus sign on it, but if you don't put a sign on, they assume it's positive, so you'll be grand. All right, identify the salt solution where most of the turnip cells would be turgid. Well, you have to remember what the definition of that word is. There's flashcards on my website. There's a link to them in the description below. You can go there and learn flashcards and learn your definitions. You really must learn your basic biology knowledge for this exam. So many of these questions rely on you knowing the meaning of this question relies on you knowing the meaning of this word. And what that word means is that the plant cell is absolutely full of water, and it can't take any more water in because the pressure of the cell wall pushing back against the water that's in the cell overcomes the osmotic pressure of the water coming in. Now that's all rather detailed, but what you just have to remember is that it's full of water, right? If the water's gone into the cell, that means that it's going to be heavier. So we're looking at the positive changes in mass, and we want the biggest one for most of the cells being turgid. So that's going to be plus 17 up here. And now we have to be really careful because it's very easy to just transfer plus 17 down to here. But what we need is the salt solution. We need that one for this answer. They help you actually with the unit. And that's this column, so we're going to put in 1. Plus 17 is 1, so stick in a 1 there. Okay, now, here's where we hit a problem. We hit this question that a lot of students have difficulty with. And this is a difficult question. It's a difficult calculation, it's a very tricky calculation, and it's easy to get it wrong. So let's see how this looks. The pieces of turnip used in this investigation all had a starting mass of 6 grams. Okay, grand. Why did they bother with percentage? Anyway, never mind. We'll have a percentage increase because we'll have the change in mass. But if they were all the same, they could have used absolute mass increase, but they've put percentage in, which is kind of annoying anyway. I mean, that's not bothering. Okay, calculate the final mass of the piece of turnip in the 8 gram per 100 centimeter cubed of salt solution. All right, so how do we calculate the percentage change? Well, we have to look at the difference in mass, and then we divide that by the starting mass and we multiply by 100. Now, what's the difference? So an increase in mass is positive. So an increase in mass is positive in this kind of question. So our formula for this is going to be end, right, minus the start. So the end mass minus the starting mass. So if you think about it, if that came out to be, I don't know, 7 minus start, we'll get a positive percentage, right? N minus start. And then we divide that by the start. We multiply by 100, and that gets us percent change. Okay? So the N minus the start divided by 100. Okay, so let's see if we can get the numbers out of here. So this piece of turnip used in the investigation is starting mass of 6 grams. So that's going to give us 6 grams. So we've got end minus 6 over 6 times 100 equals, and we know the percentage change because it's on the table. Make sure you pick the right one. 8 grams per 100 centimeter cubed. 8 grams per 100 centimeter cubed equals minus 9. All right, so far so good. Okay, well let's start off here. We're going to cancel this 100. If this side's multiplied by 100, we need to divide it by 100 to get rid of the 100. So that means we have to do the same thing to both sides of the equation. So we're going to divide that by 100. And so let's write out the whole thing again. We'll just do this step by step so it's nice and easy. I'm going to go down here. So end minus 6 divided by 6 equals, and we'll do this sum and we'll get what it is. So minus 9, make sure you put your numbers in. Let's just check that's visible under my light. That's a good spot for it there. Minus 9, make sure you put your negative in. Divided by 100 equals minus 0.09. Minus 0.09. Very easy to forget that 0 and make it 0.9. Okay? Especially if you do it in your head. Some people will just make that 0.9 rather than 0.09. Okay, so we're good to go. Now, this side is being divided by 6. In order to get rid of that 6 there, we need to multiply by 6. We have to do the same thing to the other side of the equal sign. So I'm going to cancel that and multiply this by 6. Okay, so that gets us end minus 6 equals, and let's do the calculation. We've got it on the calculator already. So I'm going to multiply that by 6. 0.54, so minus 0.54. Don't lose your minus sign. Okay. Okay, good. Right. Okay, now we're subtracting 6 from this side. In order to get that end on its own, we need to add 6. So I'm going to cancel that and add 6 over here. We have to do the same thing to both sides of the equation. So end equals minus 0.54 plus 6, which equals minus 0.54. Is that visible? Yeah. Plus 6 equals 5.46. 5.46. Okay, that's going to be in grams, right? So we'll pop that up here, 5.46. Make sure it's a reasonable answer, all right? So what are we saying? That our piece of potato has lost mass, and so that's a reasonable answer. It's just a little bit less than 6. If you've got a negative there, you can't have a negative mass. If you lose track of your negative sign, and you put a negative in here, remember that this cannot be a negative because it has to have a value. A mass must be positive. So if you put a negative sign in here, just check, because if you're talking about mass, it must be positive. So there may be you've got the negative 5.46. Just get rid of the sign. Make sure you put in 5.46. That's your answer to that. That is a tricky question. There's a couple of problems with this actually for biology students. One is, a lot of students are encouraged to do biology because they're not very good at maths, maybe, and they just don't like doing it. The other one is this actually is quite a reasonable amount of calculating in order to get 1 mark. So a lot of people may have just skipped it and left it to the end and run out of time. That's a possibility. Some people just may have got mixed up with the minus signs and the adding and the subtracting and multiplying across to get rid of your values. You could try and remember the other way of this equation already rearranged, but that's kind of hard. So there's a number of things about this question that actually make it very hard to get that mark. And I think it was a lot of work for 1 mark. Is there a shortcut to it? Not sure, probably is. But you have to remember the formulae to get the shortcuts. If you're just going to remember one formula, then this is the one you're going to remember for percentage change, right? That's the one you're going to remember, and you have to remember that because this question comes up pretty much every year. So you're going to remember this, but in this case you're going to have to rearrange it to get that value, and that's tough. That's asking a lot, I think, for 1 mark. So anyway, a tough mark to get. Did you get it in the exam last year if you did the exam? Did you get it when you were practicing the paper for your exams this year? If you did, let me know in the comments. If you didn't, tell us in the comments where you went wrong and what it is you think that, if you've got any advice about how we can improve our method here, then that's fine. But I just went through step by step just to give everyone the maths of rearranging the equation to get end on one side. And it's a fair bit of work. So it was a lot of work for 1 mark. And it doesn't surprise me that a lot of students passed it by. All right, thanks for watching this walkthrough from Doc Hill Study. I hope it helped you feel more confident about tackling these kinds of questions. Remember, the answers I've used are based on the SQA marking guide, but it's always important to understand the reasoning behind them, not just memorize the words. That's why I focus on the process, not just the final answer. If you've got any questions, or if something didn't quite click, drop a comment below and I'll get back to you. If you found this helpful, give it a like, and don't forget to subscribe so you'll be notified when the next walkthrough goes up. Good luck with your revision, and I'll see you in the next one.